All right, today we are going to talk about balancing equations. So I wrote balancing reactions, but the more I thought about it, we're not really balancing the reaction, we're balancing the equation. The reaction, of course, is what happens when the chemicals mix together and undergo certain processes where they, bond and they rearrange bonds and rearrange atoms. The equation is what I want to talk about right now. What is a chemical equation? It is sort of like a summary of a. So let's put this here. It is a summary of a chemical reaction. And by the way, the term reaction is sometimes abbreviated RXN. So it is a summary of a chemical reaction. A chemical reaction is when we mix those chemicals together and they exchange electrons, they bond, and they make bonds and break bonds. And the summary of that is the chemical equation. The way that I like to think of it is a recipe. I eat. I do bake sometimes, but mostly I'm about the eating. The good news is my daughter likes to bake, and so I'm okay for her to do the baking and me to do. All right, so we're back. So I like to think of it as a recipe, meaning if you add some of this and some of that, you will end up with this or the other. One thing to remember about recipes, if we're going to make chocolate chip cookies, because we know that Mr. Willis likes homemade chocolate chip cookies, you might start with 2 cups of flour, 1 cup of sugar, or whatever, but your primary measurements are going to be cups, half cups, things like that. Then we got some tablespoons maybe and some teaspoons. Here's the deal. In chemical equations, what do you think we measure in? Moles. And so we will be mixing, say, 2 moles of this and 1 mole of that to make 3 moles of the other and, 1 mole of a 4th thing. So anyway, so we're talking about recipes and doing a little chemistry cooking. All right. Now, there is an idea called the law of conservation of mass. The law of conservation of mass says that, what I'll tell you is that chemical equations must be balanced on both sides according to the law of conservation of mass. The law of conservation of mass, which you guys have heard of before, says that matter cannot be created or destroyed. In other words, new stuff does not just show up out of nowhere. And stuff that you already have doesn't just disappear. All right? And you don't get more and you don't have less. In other words, you have to start and finish with the same stuff. Here's how you can summarize the law of conservation of mass. You have to start and finish with the same amounts of the same stuff. And when I say stuff, I mean elements like carbon, hydrogen, oxygen, nitrogen, sodium, whatever. But whatever you start with, you have to finish with the same amount and the same material. All right? You do not have new stuff randomly showing up. You do not have old stuff mysteriously disappearing. And you don't get double for nothing. And so what this says is that the atoms that are present on one side must be present on the other side. Ooh, sides. Hey, what do we call So let's see. I'm gonna back up here for a second. And if I've got, if I've got material A and substance B, and I mix them together to create molecule C and compound D. What do we call the material that we start with? Yeah, we call that the reactants. What do we call the material that we finish with? The products. Very good. All right, so we have the reactants and the products. And you need to finish with the same stuff that you started with. All right, so here's an example. So let's say that we have, so we all know the recipe for water. A little bit of hydrogen, a little bit of oxygen. Mix it together, stir it around. All right, react it together, and you make some water. Okay, H2 plus O2. Oh, now remember that hydrogen and oxygen are elements that we call diatomic. What does that mean? That they only exist as two atoms. Okay? And so if they're by themselves, they are not running around as singles. They're running around as pairs of that element. All right? And so diatomic elements are always found in pairs, not just by themselves. All right? So we've got some H2 and some O2, and we mix those together, and we get H2O, water. Here's the trouble, though. How many hydrogens do we have on the reactant side? 1, 2. Okay? So I'm just gonna make a little chart and keep track. So there are 2 hydrogens on the reactant side. How many are there on the product side? 2. Hey, that's looking promising. We started with 2, we finished with 2. Hey, same amount, same stuff, yay. The other thing that we have on the reactant side is oxygen. How many did we start with? On the reactant side. All right, I will give you a hint. It's 2. And how many are there on the product side? Only 1. And so the question is, what happened? This is not okay that we only have 1 oxygen when we started with 2. Okay? And so what that means is that now we started with H and O and we finished with H and O. So we have the right ingredients. We started with and finished with the same stuff, but we finished with the wrong ratios, which means that our recipe is a little off. Okay, we need to change the ratios of our recipe. All right, and this is what we call unbalanced. Okay, meaning that the numbers do not match on both sides. If they did match on both sides, it would be balanced, but they don't, so it's unbalanced. All right? Now, I don't know that you need to write, we've probably already written this down. You started with 2 on each side, you finished with 2 and 1, and so something is wrong. And what I want you to know about this is that this has a star, and I want you to, a little asterisk, and I definitely want you to write the asterisk, and then maybe write another star, and then maybe write another asterisk, and maybe make some exclamation points. This is super important. To balance an equation, you may only change the coefficient, which is the number in front of the compound. You may not change any subscripts. What's a subscript? Yeah, the tiny number behind it. So that is it right there. That's a subscript. You may not change any of those. Because at that point you would actually be altering what is produced, and you do not have that ability as the chemist in the lab. You cannot alter the way that nature functions. Now, you could choose to manipulate that by controlling what you react. But Andrew, if you've decided, hey, I'm going to react these things, you can't then decide, but I don't really like that product. I want it to be different. Okay, no, thank you for playing, but you are not that powerful. You do not have that choice. Okay? So you may not change any subscripts. However, you may change coefficients. Coefficients simply refer to quantities. Okay, and so by changing that, you're saying, oh, so I really wouldn't get only this much. I really should get that much. And so it's a matter of realizing, hey, do I need 2 cups of sugar? Do I need 3 cups of sugar? Do I need 1 cup of milk? Do I need 2 cups of milk? Will I get 1 dozen cookies? Will I get 3 dozen cookies? It's a matter of looking at your ingredients and looking at the ratios and knowing what's going to come out on the other side. All right, so that's what our balancing is going to be about. Now, hey, let's just come back up here to our reaction and see if we can do this on our own. All right, because I'm a fan of just trying this out. Now, I have 2 oxygens over here, which means I need to get 2 on this side. What could I change? Where could I put a number to get 2 oxygens? Well, the only place I can put a number is out here in front. So I'm going to put a 2 right there.
So just on oxygen,
Why can't you what?
Why can't you put it in front of the substance?
Like meaning put it right here?
Yeah, like put it
Because you can only, because remember, we're producing water as a substance, as a compound. You cannot only produce more oxygen. You have to produce the water as a compound at this point. And so that's why. That's a great question. Yes, sir?
When you do that, when that turns to 4 hydrogen?
All right, so you have noticed a problem. That's going to fix my oxygens, but it's going to mess up my hydrogens. Because when I get 2 oxygens, that's also going to produce 4 hydrogens. Well, what could we do? So we got 4 here, so now let's see if we can get 4 on the other side. Ooh, lucky thing. If I put a 2 right there, now 4 and 4, check. 2 and 2, check. And so we're all balanced. So here's what that means. You don't just put 1 mole of hydrogen and 1 mole of oxygen. You have to mix them in a 2 moles hydrogen to 1 mole oxygen ratio, and in the process you produce 2 moles of water. All right? So it mixes in a 2-to-1 ratio to produce 2 moles of product. And that's what we've just learned from balancing our reaction. So it helps us to know what ratios the materials will react in. All right? Are there questions about that? All right. Hey, this is not a deep mystery. It's just a matter of counting atoms and knowing that whatever you have to start with, you have to finish with. So if you didn't have enough to start, you need more. And if you had too much to start, you need more at the end. All right? So it's just a matter of counting. So let's look at that. Let's see. And this is exactly what we did. We added a 2 in front of the water. Oh no, that messed it up. We got 4 hydrogens. Okay, oh no, dun, dun, dun. Hey, it's still unbalanced, but when we put a 2 in front of the hydrogens, dun, 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 dun. I know. I told you I was not feeling motivated today, and and it's time for the week to be over.
Mr. Willis, you should become a choir teacher.
I should not become a choir teacher.
I think you would send many students to all state choir.
I would send many students to Allstate like the insurance company. Okay. So here we go. And then we recount again and we get 4, 4, 2, 2, and that's exactly what we saw at the top. So here's what we need to see, that our balanced equation is in fact 2 moles hydrogen to 1 mole oxygen to produce 2 moles of water. And that's the same thing that we saw up top when we worked through. All right? So that is the basics of balancing equations. Let's real quickly work through a couple of samples. Okay?
Are we on page 1?
Well, I'm gonna look at page 1. If you want to look, you may. And actually, I'm gonna do number 2 first.
Oh, on the back. Wait.
No, the one balancing equations worksheet, and I'm gonna work number 2. I'll tell you later. But right now, I'm gonna work number 2. Number 2, we end up with silver fluoride, and we combine it with calcium chloride to produce or to yield silver chloride and calcium fluoride. Now, the first thing that we need to do is we need to make, bless you, a list of the stuff. We need to list out our ingredients. We have some silver, so I'm going to list it right here in the middle. Why in the middle? So that we can actually record numbers on each side. So I've got some silver, I've got some fluorine, I've got some calcium, I've got some chlorine. All right, silver, fluorine, calcium, chlorine. There you go. I know I feel like we should be jumping rope. A little children's rhyme or something. I think. Hey, how many silver atoms are present in this?
1.
Okay, 1. How many silvers are present on the product side? 1. Hey, this looks promising. Fluorine? 1.
And
Fluorine, whoops. And it all falls apart.
You jinxed it, Mr. Wilson.
Calcium?
1.
So first thing we do is we record all our numbers. Calcium? Ooh. Chlorine? 2. Chlorine? Oh, 1. Okay. All right. So match. So we've got a little bit of work to do. Hey, here's the thing. I need more fluorine on this side. So what I'm going to do is I'm going to put a 2 right here to produce, in order to account for that extra fluorine. All right? So 2. And that's going to, hey, watch, I'm just going to scratch this number out. All right? So now, if you change one, anytime you put a coefficient in, you need to look at every element that was present in that. So I just changed my fluorine, but I also changed my silver. Whoops. So I fixed one thing and messed up another. Well, here's what I'm going to do. I'm going to go ahead and see if I can fix my silver. So I'm going to put a 2 here to try and fix my silver. And when I do, I fix my silver up, and I've changed my chlorine also. So now I have an O. Happy surprise, a serendipitous experience. We have fixed our chlorines in the process. And so all of a sudden, let's see, match, done. And so there is our balanced reaction. Okay?
So basically, you're just playing a big game with calculating from this.
Yeah, you were just playing a little bit of a counting game and seeing what you need to change to make it work. Hey, all right. So now we will go back and look at 1. 1 is actually a little more complicated. I don't know why they did this. So 1 is I've got some aluminum nitrate. And some ammonium phosphate. Good job, good job. And that's going to yield aluminum phosphate and ammonium nitrate.
I'm getting so much better.
Not to burst your bubble, but it is easier to go from symbols to.
I'm in class.
All right. I'll leave you alone. Good job. Now, hey, here's what I want to do. We need to account for these as individual atoms. All right. So I'm looking and I'm seeing. Let's see. I think I just. Oh, there we go. So I'm looking and I'm seeing some aluminum. Oh. All right. Some aluminum. The struggle is real. Some nitrogen. Some oxygen. Some more nitrogen, but that still is in the same thing. Some hydrogen. And a phosphorus. All right, let's do some counting. One aluminum. Nitrogen. 3 times 1 is, plus 3 times 1 is, all right, so I got a total of 6 on that side. One, that's only 1. Because that 4, this is not in parentheses. Oh, sorry. So 1 nitrogen and 1 nitrogen, I've got 2. Hey, now to oxygen. 3 times 3 is 9. 3 times 3 is 9, plus 4 is 13.
I sacrificed my math for nomenclature.
There you go. Oxygen here, 4 and 3 is 7. Ooh, this is looking a mess. Hydrogen, 4 times 3, 12. Over here, just 4. And phosphorus, 1 and 1.
I mean, at least the first and the last one are dollars.
At least the first, and honestly, if they weren't, that's where I would have started. So that's a little bit of. So what I'll tell you is, this is just a little hint. Save elements that are by themselves for last. Save elements that are alone for last. All right? And here's why. Because at that point, you can finish balancing that without messing up anything else. All right? So always save elements that are alone for last. And I also like to save hydrogen and oxygen for last, and nitrogen, because they are frequently found in more than one. So you've got oxygen here and there, and there, and there. And so if you change anything, you're changing your oxygen number. Don't try to balance your oxygens early, because then when you change anything else, you'll unbalance them. Save your oxygen for later. All right? So elements that are alone for last, and I like to save oxygen and hydrogen for next to last. All right. Here's what I'm going to tell you. At this point, it would turn into a hot mess of trying to rearrange and deciding what to start with and where to start putting numbers. However, here's what I'm going to tell you. This is not a hard and fast rule, but it's something that you can use. All right? So what I'm telling you is a rule of thumb, trick of the trade. It's not really a rule so much as a guideline. Okay? So they're not really rules, more like guidelines. Yeah. Hey, so here's what I'm going to tell you. If you have polyatomic ions, that stay together, try to balance them as a group and see what happens. Okay? Hey, you see how my nitrates stay together as a group and my ammoniums stay together as a group? Let's see if we can balance those together as a group. So here's what I'm going to do. How many nitrates do I have?
Nitrates?
3? So I've got nitrates here. I'm just going to put a 3. Now that's going to give me 3 nitrates. It also gives me 3 ammoniums. Ooh, that's how many I needed. So again, a happy circumstance. So now I've got 3 ammoniums, 3 nitrates, my aluminum, and then 1 phosphate. So that may actually work for us. Let's count the individual atoms again. Aluminum, 1 and 1. Nitrogen, 1, 2, 3, 4, 5, 6, still 6. Nitrogen over here, 3 times 1 is 3. 3 times 1 is 3 more. So that's looking good. Oxygen, 3 times 3 is 9. Plus 4, 13 still. Okay, let's see. 3 times 3 is 9. And 4 more. 13. This is looking good. This is looking good. Still 3 times 4, 12. Where are my hydrogens? 3 times 4, 12. And phosphorus, 1 and 1. And so you can't, strictly speaking, balance using the polyatomics. You have to balance using atoms because, hey, polyatomics don't always stay together. They can break apart and get rearranged. And so that is not a strategy you can use all the time. But if they stay together, that can be a really helpful tool to kind of look at groups rather than individuals. Hey, but if you're trying to do that and it's not working out, then leave that strategy and go back to atoms. Okay? Questions about that? All right. So that is going to end our discussion on balancing equations. All right. You've got some practice pages. You don't have to do all of them, but you will need to do some. We'll do a little more work either tomorrow or Monday. I'll think about it and decide what I want to do. All right. But that's going to be it for balancing for today.